Hey guys, we're gonna get started in about 5 to 10 minutes. Let people come on in. But I have the slide here on what we're gonna be covering today. Let me know if anyone has some questions before we get started. I'd be happy to answer them. Hey everyone.
I do have one question. Is there a specific version of Unity that we're using?
No version specific. You can pretty much use any version and it should work
All right.
fine.
Neat.
All right guys, I'm gonna get started with the workshop now. I am Samuel Arminana. I am the co-founder of Unlock Studios. I'm going to be doing a Unity C# real-time networking workshop. I'm doing this with the Game Dev Nights Club at University of Central Florida. Today we're going to be first understanding a little bit more about what networking is and the concepts behind real-time networking. Then we're going to get started with Unity and give a brief overview of what the different windows do and how to code C# within Unity. Next, we're going to create a C# console TCP server, and that's going to be a separate application totally from Unity. And it's going to run in a Windows console. And then we're going to create the client within Unity, and that's going to be running within Unity's libraries. We're going to be sending strings back and forth with the header, and we're going to be making a chat app with that. And potentially, if we do have time, we can really quickly create a tic-tac-toe game pretty quickly. So first, getting familiar with networking, what we're going to be creating today is the game server aspect and the client aspect of the networking. So the game server is going to be, like I said, a console, and it's going to be hosted on a computer address. And you open up a IP address, and you can listen to that IP address. So you either have a local access network IP address, which would be like 192.168, and that would be only accessible locally. And then you have public IP addresses, which are automatically assigned to you by your internet service provider. And those ones can be accessed by people outside of your network. So that's what allows a server to listen to connections um, through the IP address. And this server is going to be handling the join requests from the client, and will maintain a list of all the clients that have joined it. The client is going to be running in Unity, and it's going to be joining the game server by providing the IP address of the server. And once connected, the game will load based on data received from the server once connected. So first, once the client has connected to the game server by the IP address, then the game server can confirm that they have received the request, and then they can flow data between each other now once connected. This is a bigger overview on a more complete game server architecture where you have a database along with a web server feeding using a API to communicate with the web server and the client, and the web server communicates with the database. So like, let's say you have a Call of Duty type of game where you're keeping track of kills and deaths and score. That would be like lifetime. So what would happen on the client side would request that information using their username and password. It would get their lifetime score, kills and deaths, and then the client has access to it. And then the server would have a direct connection to it, since it doesn't need to go through an API to authorize the request, since it is the server and it's automatically authorized. You could even host the server on the same server as the database. So it'd be a local request, but it would then be able to interact with the database and with the user's data. So it can alter all the users in a match. It can change their lifetime scores and kills and deaths once the match is over based on the information it got within that match. I'll go over this some more. I'm sure this will make more sense as we go through the workshop more, but I thought I'd bring this up, and I'm going to go through it again once we're complete. So don't be afraid to ask questions if you have any. So what does real-time networking mean? Real-time networking means you're sending data where the input doesn't ever lag behind the outputs. So you're always sending something in, getting something out, and you're not getting more things back than you put in. And data must always meet certain specified deadlines. For example, 10 seconds to timeout, that has to be a consistent thing. And also, like, a request can't take longer than, let's say, like 5,000 milliseconds, so 5 seconds. That would be a requirement and a specified deadline, and that would determine a real-time networked game. But you traditionally see it in games that uh, transmit data at more frequent intervals within the second. So they're more consistent and they appear to be updating regularly instead of like every 10 seconds as seen here. But um, another example of real-time networking here is Zoo Kazoo, where you have like a little sprite character that moves around a map. And so that would be an example of real-time networking where you're transmitting chat data and position data for the characters.
Real quick, I don't know if you can see the chat, but Santi asked what an IP address is.
An IP address is, it'll make more sense once we start connecting to the server and like actually define the IP address that we're going to be connecting and stuff. But you can think of it as like an address. When you send any networked request, it would have to go to a specific IP address, and that would be a location. So your public IP address, everyone has one if you're connected to the internet, and it's assigned to you automatically. So anyone would be able to connect to your IP address, but whether it gets accepted or listened to is a different story, or whether your firewall accepts it or not. But yeah, it's just, you can think of it as like a location that you're going to be sending information to. And Christian, there's no particular version of Unity that we should be getting, that you should have installed. You can pretty much use any version as long as you have it, and as long as you also have Visual Studio. All right, so what is a server and client? We were talking about the server and the client and had the diagram with the server transmitting data to and from the client. So the server is, as we said, it's an application that that we created that we're going to be providing functionality to the clients who are connected to it. So any server is basically anything that provides any kind of service to clients who connect to it. You can think of like the HTML server that's hosting your website as a server, or a computer running a Minecraft server console application. And some multiplayer games even have some kind of mechanics that allow clients to act as server hosts. And so they act as the host by relaying data and authenticating that information is correct. There's different styles of client-side server app relationships in the games. You can have an authoritative server, which means that the server determines the client state based on inputs. So for example, let's say it's CSGO, a competitive first-person shooter. The client would be sending its input when the player presses W, and the server would apply acceleration onto its own physics simulation, and then output that result back to the client. So here there's an example between the client sending an action move right 1 unit to the server, and then the server returns the new state of the player. So the server is ultimately always authorizing every action, and it can also have its own logic to deny a request. And then there's dumb clients. read this on Gabriel Gambetta's blog post going over the different client-server relationships. And this is where the client is handling its own physics simulation and tells the server where it's at. So in this case, it would be the client would send its new state of 1110 to the server, and then the server would just automatically accept that as being true without having its own way of authenticating that as being accurate. Old Minecraft is an example of the dumb client server because a user could set their location client side to a certain vector 3. So you could say like you're at the center of the universe, and then the server would automatically send that to everyone else. And this caused a surge in cheating, but was easily overcame by adding in plugins that would add in their own logic onto the server to confirm that clients' actions aren't actually totally incorrect. But it's just something to consider between having just a server that just relays information versus a server that's actually providing its own physics simulations and authenticating that input is actually correct. So it's kind of more putting your logic, your game logic on the client, on the server versus the client is what is ideal. And then finally, what is TCP/UDP? For this workshop, we're only going to be using TCP. UDP would really be easily applicable with what we're going to be doing, since it's going to be a separate internet protocol that you would basically just be using. You would have to handle a few things differently. We'll go over that later, but both are networking protocols and establish rules for how the computer should transmit data. They're part of the transport layer in the OSI model. This is a model that describes how data is being transported to a application from every step in the process. So from transmitting raw bitstream over physical medium, that would be your actual physical wires, to the application layer, which is the C# code, which is what we're going to be writing. So there's a ton of stuff that happens between we getting data and it being transmitted. So this is part of the transport layer, and it gives us a little bit of control here where we can decide what protocols we want to use, whether it's TCP or UDP, and there's a ton of other protocols that you can use, and a lot more advanced ones that combine the two and make their own like unique protocol. But these are the most standard protocols used pretty much everywhere. TCP connections are always connected, and that means that packets are always going to be delivered, and they also are going to be delivered in the correct order. TCP will perform a checksum at the end and require that the data that was sent from the client or from the server was received in the correct order, and that it was also received completely. And if it wasn't received completely, it will resend it until it gets it completely. So this is useful for sending data that is things like health changes or damage events, things that always need to be sent, and you need to make sure that they're always sent. UDP connections, however, are unreliable because UDP connections are typically regularly disconnected and sometimes have to be reconnected, and then sometimes the message may deliver. UDP is responsible for packet loss, so messages sometimes get delivered in that way and get corrupted. So it's useful for sending voice data, getting user input in a fast-paced FPS, etc. So like I said, with the server being authoritative, where you're getting input, you would want to use UDP because you're going to be sending in input like pretty much every frame that the user is connected to. So you want to kind of be knowledgeable of what you're using, and there are ways around using these two different protocols in different ways too, with third-party libraries and different protocols that have been developed over the years that allow you to use a singular one, and you can get the benefits of both. But as I said, this is kind of what's built in automatically and native. So this is going back to the diagram that we addressed earlier. Kind of just want to go over it again. The client is going to be connecting to the game server by the IP, and then they're going to get added to the game server's user list. And then the game server is going to keep track of all the clients that have connected to it and be able to send and receive data between each client that it decides. And the client will be connected to the server and be able to send data only to the server. Whether we add in logic for the server to propagate data and broadcast a event from a particular client to all events, like let's say someone sends a chat message, you want to send that chat message to every other client, every single client connected, you would just send it to every client and broadcast that. So that's how you would add in functionality from one client to another client via a server. Next is the little sales pitch for Unity. Unity is a 3D cross-platform real-time rendering engine. It's used to create movies, business apps, and VR, AR applications. You can export pretty much universally and to a ton of platforms, from Samsung watches to Xbox One and the new Xbox. I don't even know the name. So 60% of AR, VR content is powered through Unity. 50% of mobile games are powered through Unity. And it's a really big emerging market for jobs. Yeah, you can also export to Tesla. There's a integration to Tesla coming. All right, so if you're not familiar with Unity's interface, I want to go through and give a brief overview. First, the project window is down here below, and this lets you view all the files within your project that you have open. The scene window shows you the currently loaded level that you're in, and because Unity is a game engine, things are in terms of games. So the scene, every level in Unity pretty much is a scene, and this is where you keep your game objects. Your game objects are in the hierarchy. They're listed out individually, and you can click on them. Each of the game objects are objects that exist in the scene. So here you can see in the scene, there's a icon for the camera and the sky and the sun. So you can click on those two things and they would go to the two other game objects there. Next is the inspector. Once you're selecting any object in Unity, the inspector can give you information on it, and you can also interact with anything relating to it. So here I have a game object selected, so it will give me the inspector for a game object. And you can change the name and add different attributes to it. And then there's a transform component, and that lets you change the position, rotation, and scale. So if you had any objects that were children of this, and this was a parent of them, then that would affect their position, rotation, and scale as well. So Unity is component-based. When you create a C# script, you're going to be adding a new component. You'll see it here. So this is a example script that I just dropped on the component. I'm not going to go over prefabs. So if you're not familiar with coding in Unity and C#, you basically just need a script to be inheriting from a mono behavior, a C# script to be inheriting from a mono behavior. And that will give you the functionality to interact with the engine and the Unity library. So every mono behavior has certain events that are called that you can hook onto. And if you declare these as functions in your class, they'll be called. So the awake function is loaded as soon as the game starts and before start, and then start as soon as the game starts. Update is called every frame in the main loop. Unity is single threaded. They have support for multi-threads, but the main engine is running on a single main loop. And so this is the loop that's going to be running in the that's running your game. And late update, fixed update, we're not going to get into those, but those are called at fixed time steps, fixed time steps, and those are independent from update and are used for physics calculations. So ideally, you would set your fixed update time to be whatever your sync time is if you were running physics simulations. So here is a example C# script. It has a namespace that is just determining what folder it is in. And next is a public class declaration with the mono behavior being inherited. And then you have the awake, start, and update functions. And if you put any console write line commands in there, they would all print out accordingly. And you would see awake get called first, and then start, and then update, looping on from then on. So you can also add in variables and change them in Unity in the inspector. So here I have some examples. If they're public, you can view them. If they're private, you can't view them unless they're serialized. So Unity will automatically mark all public variables as serialized, which means that it can be stored in data and that it can be saved and then loaded. And if you have it as private, it won't be automatically serialized unless you have that serialized field to manually mark it to serialize. Structs and classes also have to be serializable if you want to reference them within your inspector and have it save and load. And it has the same structure as the classes, as in you have to declare public and private and serialized field. You also have support for arrays and lists. Unity doesn't have a inspector for dictionaries though. You can get assets that do provide that functionality, but out of the box it doesn't have a display for a dictionary, but you can use it in code. You just won't be able to view it physically, and it will be serialized. I also have a Kahoot game, but I think it's a little too early, but we'll get to it at another break soon. I have a Unity asset. It's Dark Rift Networking 2 Pro. It's a $95 value. And this is a networking asset that does basic socket networking, and it also provides all these different plugins that are user created. And it basically just gives you a unified language in which you can create a networked experience. And it also provides all those plugins that you can also create on your own and you can download from the community. But I'll get back to this later and we'll play the Kahoot game when we're on a break. So first we're going to be creating a .NET Core cross-platform C# Windows console application. This is going to accept input from the console for what IP and port to listen to for traffic. It's going to open a TCP connection. And as I said, UDP was planned, however, due to time, it was impossible to add in. I have a Stack Overflow with a perfect example of client and a server on a TCP and UDP, having both connections open, communicating data back and forth. So that would be a great resource if you're looking into also providing UDP. And if you're looking into any other protocols, I would greatly suggest that, as they're more modernized and kind of easier to work with. Console applications, the console application is going to handle the game logic, and it's going to receive events from the client in Unity. So as I said, we're going to be using headers to determine what messages are. So we're going to say, we're going to tell the server like 0, and then we're going to send a string along with it. And depending on whether it's 0, 1, or 2 for the header, it will perform a different action with the string that was given. We'll get into that a little bit more as we write the actual client and server communication. So why not create the server in Unity instead of creating a console application? We totally could, but this is to give you an idea of how to create a server that doesn't need to be on the same code base as your client. We're just going to be writing code that communicates with just bytes, and the server and client will be coded on different projects, but we'll be using the same way of reading and sending data. So they'll both be able to communicate to each other, but they'll be on totally separate projects. So what are the pros of using a server inside of Unity? It just means that we're running our server in Unity's framework, and we're able to utilize their Unity engine libraries. Unity engine powers the engine's physics simulations and also gives you everything else that the Unity engine provides. It also lets you replicate logic on the client and the server if you're using the same physics simulation. So if you wanted to replicate the physics simulation on the server and have your server act as an authoritative server, it would have to run the same physics simulation as the client. So they would have to be in perfect sync, basically. And if they're not in perfect sync, the client would reset up itself so that it's in the same sync as the server. It would reposition itself if its position isn't correct based off the server, and basically do it in a smooth way where it's not noticeable to the user, but to everyone else, they're in the correct position, but they might be slowly inching back to it. You can also build a headless Linux build and execute it with console arguments. This means that you can run your Unity build in a Linux console, or you can just run it, or you can just run it as a application just in the console. It doesn't have to be open as a full window, and it doesn't have to be open in Linux any other way. It can also read console arguments. So if you were creating a server Linux build, you would start it up giving it an IP and port to connect with, and any other arguments that you need to configure your server with. So let's go ahead and get started with creating this server. We're going to open up Visual Studio 2019, or pretty much any Visual Studio. You should have the option to create a C# console app. We're going to use .NET Core here. And do not use Visual Basic. Make sure you're using C#. So I'm going to call this Networking Workshop Server. I'm gonna place it inside of the networking workshop folder I made here and create it. I see a question about whether some concepts will transfer to Unreal. I'm not sure. I don't know too much about Unreal's networking. I know that they provide their own separate like framework completely on top of native sockets. So you might want to look into that as well. But it should transfer over through C++ because C++ does also have socket networked programming. All right, so here we have our new application, new project. If I hit play on the top and build it, you'll see it opens up a new Visual Studio debug console, and this is just a terminal. So we can write information here. We can also accept information. We can do console.readline. And then at the end, we can write out what they say. So if I hit play, so it's pretty straightforward. We're going to be now using we're going to be using this to get information about what IP and what port we want to be setting the server up to. So first we're going to be asking for the IP.
Hey Sam, can you zoom in on what you're writing a bit?
Sure.
Thank you.
All right. So we're just going to ask for the IP and port. All right, next we're gonna just confirm. So first we're gonna have to create a new thread here. Actually, before we get to that, let's first define our socket here. All right, sorry for the chaos. So we're gonna declare a public variable here that is a socket. And in order for this to be a reference variable, you need to be using system.net.sockets. So this allows you to get into a namespace and use references that are defined in a specific namespace. So for example, here, if I had the namespace example, and then I had the public class example class, I wouldn't be able to reference example class unless I'm using example. Or I can also hard reference it and also do it like that, as I could here. So I can always do system.net.sockets. And then it would always know that it needs to go to this specific namespace. But using it works fine, and we're not using the word socket for any classes within this namespace, so it should be good. Next, I'm going to create another class here called server and create a public void setup, which accepts a IP and also accepts an input for port. We'll use a string for now, but we'll need to convert that to a integer. So I'm going to move this public socket declaration here to the server. And so this server socket here, I'm going to construct it. It has a constructor which requires some configurations. So first, the socket type. This is going to be using internetwork. This uses IPv4, and you can define different address families. I'm not too familiar with what the different address families do besides IPv4 and IPv6, just two different types of IPs. And the way they're defined is a little different. But we're going to be using internetwork, which is going to allow us to use the regular IPs that we have. The socket, next we're going to declare the socket type. And the socket type here is going to be a stream. And then the protocol type, we're going to be using TCP. And you can use different protocols here, even UDP. That would require different logic. For example, we would have to check if we're disconnected to handle reconnecting smoothly. But we're going to continue using TCP here. So let me move that console.write here below. And next declare a public static server. And we'll just call it server. And then we'll declare a new instance of server here inside the main function. So we're going to call the setup. And we're going to feed it the IP and port. So we're going to get the server socket, and we're going to call the bind function on it. And this is going to allow us to bind it to a specific IP address and to a port. So I'm going to create a new IP endpoint, as this is the constructor that it requires here. You're going to require the system.net namespace as well. And then within this lets us create a new IP endpoint with an address and port. So the IP address has to be parsed from a string into an actual IP address. So there's a class called IP address under system.net, and this allows us to do parse. And within it, you can put in a string like IP. And then for the port, it would just be an integer. And since it's a string, we would be able to do int.parse port. So here you can see we're parsing both the IP address and the integer. So IP address is, you can think of it as the same as integer, and we're just parsing it and turning it into an IP address. So once that's
sorry, real quick. Colby's asking if he can't find the .NET Core template. Does he need to install something for that?
ooh, you don't see the .NET Core template at all? Yes, you might need to actually. Let me get you the link to that. Do you see any console application? All right, I sent a link for the .NET Core framework installation. You should be also able to go inside of Visual Studio, and I'm not sure where is the... But yeah, if you can't create a console application, that might be a problem. Is anyone else having trouble creating a console app? Yeah, I don't even know where I would look for that.
Yeah, you'd have to go to the Visual Studio installer, and you'd have to like add in. You'd modify Visual Studio to add in the .NET stuff.
Yeah.
Yeah.
Yeah,
like-
see if
like
you're
Chris
able
said,
to
yeah.
open that application up. Here we go.
Oh, rip.
Yeah, no, let's get out of here before it makes me update. But that should allow you to install the needed stuff.
Yeah. Jennifer also asked the listen is for a certain port.
No. So the listen here, this is accepting an integer for the backlog as input. So if I go to it, you can see it's accepting backlog. This means how many requests will be kept before it starts just ignoring them. So I'm gonna set it to just 100. Doesn't seem too bad. All right, so once the server socket is opened and we are listening, then we can start accepting connections to it. So I'm gonna create a private void here. And I can also change the variable server socket to private. Create a private void here, call it begin accepting. So we're going to call the function begin accept on the server socket. This is going to be expecting a callback and a object state. The object state we can use null, but for the callback, we're going to have something there. And we're going to call this accepted connection. And we're going to create a new function called accepted connection as well. So this is going to accept a function as an input. And once a connection is accepted, it will call this function, but it's got an error here, and that's because it's missing a variable that's required for this to become a acceptable callback. Sorry, it needs an async result. So this is just a multi-threaded asynchronous task. So this task will contain some information here. Let me first call this. So we're going to first begin accepting. We're going to tell the server socket to begin accept. And once we have a connection, it's going to accept the connection. So first we're going to check if the server socket is equal to null. We're just going to return. So this is going to be a check if the server socket, for whatever reason, just disappeared. We would be able to not error here. So first we're going to declare a new socket here. And we're going to call it server socket.endAccept. So this is going to end accepting the socket based off the result we have once the connection's been completely processed. So this is going to be the final step where we're manually accepting the connection. And here we can then perform logic and either kick them out if the server is too full, or we can send them a username that we generate or whatever else. So first I'm gonna make a little message here that we received the connection. So we're just gonna output some information about the socket, and it's just gonna be the address family. And so it should be internetwork, because we're going to be also using the console in the same address family. Next, we're going to start accepting again. So this is going to be an infinite process where we're just beginning to accept. Once we've accepted, begin accepting again. Now, once we have a connection, we can actually start receiving data. But first, let's make sure we can actually connect from a client and make sure that this is actually running. So I'm going to start a new build here. So here this created a server, and then it just shut down. And we don't want that. So we are going to want to start a while loop here. So I'm going to declare a static function back in our program class called listen for commands. This is going to have a while true. And what we're going to do is have a string called command, and it's going to be console.readLine. So we can have a check if command is equal to exit. then we can just break the loop, and then it should close the console. So now it should start infinitely accepting commands until we send exit, and then it'll break out. So we can use this listen for commands function also to perform commands manually from the server. So I'm just gonna leave this up for a second. Next up, we're gonna be creating the client, and the client's gonna open up a connection like the server, and it's going to start receiving data from the server once we get the connection going. But so far, we're binding to the IP and port. We're creating the server socket to listen to up to 100 queries before it starts rejecting them. And then we're going to tell it to start accepting. Once it's accepted, it's going to call accepted connection, and then we're going to loop back to begin accepting. And this isn't limited to 100 queries. This is limited to 100 queries in the backlog. And that just means once a network request is processed, it will exit out of the backlog. And then you'll have space for another request. So let's create a new Unity C# project inside of Unity Hub. So I'm gonna click on new here. I'm gonna make it a 2D one. And I'm gonna set the folder here to the networking workshop. And I'm gonna call this networking workshop client. And hit create. It's gonna take a second to create that. Finally. All right, so I'm going to create a new folder inside of Unity called scripts. If you just started Unity for the first time, you might be seeing it in this layout. Default. This is what I had in the presentation. I prefer using the 2x3, which moves the project window up to the right and moves the scene and game right on top of each other. And then I prefer the one column layout versus two. It just seems a little cleaner in my opinion. So I'm gonna create a C# script here and call it client. And I also want to create one called client manager. So I'm gonna open up both of those. So these are the default functions that come inside the class. So I'm going to get rid of all those. And I'm going to keep it as a mono behavior. And I'm going to do similar to what I did with the server, create a new socket here. I need to be using the correct namespace. And Unity isn't a separate is not a separate environment from C#. Like you can access the system libraries and all that. You just have to be careful when you're working cross-platform in case some things don't work. But mono behaviors and mono, which is a extension of C#, which is it's a runtime library and lets you run this run C# on different operating systems. So it has handlers for sockets, which allow you to run cross-platform. Like you can run sockets on Android and iOS and on PC, Linux, and Mac and stuff like that. It just certain platforms might not support it. So you just need to be careful when you're using libraries outside of Unity that aren't confirmed to be working for whatever platform you're working with. So this client socket, I'm going to declare a new one as I did before, and I'm going to declare the address family as internetwork, the socket type as a stream, and then the protocol here I'm going to set as a TCP, as I did before. And I'm going to declare a public void function IP. And I'm going to set a default IP of 127.0.0.1. And this is your local IP. You can also replace this with localhost, and to the computer, it'll still be recognized as the same address technically. And then we're going to accept the port here. We're going to use 25565. If you're not aware, 25565 is the port used for Minecraft. If you ever had a Minecraft server, you'll know what I'm talking about. And then we're going to create a callback action here. I'll actually get rid of this. We won't need this for right now. Just for getting the connection recognized. So first we're going to check if client socket is equal to null. And we'll return, but that should never be the case since we declared above. So if client socket dot connected is a Boolean, and this will return whether or not this client socket is connected. So before we connect, we want to check if we're connected. We'll want to disconnect. So to disconnect, you have to shut down the socket. And you can shut down both ends, or you can shut down receiving or sending. So we're going to shut down on both. And then we're going to close it. Next, we're going to want to create an IEnumerator and call this connect coroutine. And inside of our start function, we are going to call start coroutine connect coroutine. An IEnumerator is specific to Unity, and this allows you to create a wait in time. So you could yield return new wait for seconds. So this allows you to wait a specific amount of time. You could create your own threads and use multi-threaded and use asynchronous delays. But we'll want to try working with what Unity has for the workshop because IEnumerators work with Unity and they're built in. However, asynchronous functions won't work within web builds. So if you're using WebGL, your asynchronous functions won't run and you'll get an error. And if we're using what Unity has and provides, then it does work. So you'll just have to keep that in mind if you're working on certain platforms, whether they support asynchronous functions or not. But this will work completely within Unity. We're going to make some asynchronous functions in the server, and you'll see an example of that, and you can see kind of how you would do it inside of Unity if you were to redo it using their IEnumerator. So this is going to be a while loop. So while we're not connected, we're going to repeat this process. And I'm going to put yield return null here, because otherwise the function will return an error until you have some kind of yield return. So yield return null, it just will wait until the next frame. You could also do yield return new wait for end of frame, which they both do the same thing. But if you declare a new wait for end frame, this is a data type that actually will declare garbage. So you could always do something like that, and you'll always have that reference to wait for end of frame. So you could repeat this like forever, and then you have a single wait for end of frame reference that's being used and is being cached. But I'm just going to yield return null, and it works exactly the same way. And while we're not connected, we're going to attempt to connect. So I'm going to hold a integer for the amount of attempts we've attempted. Increment it by 1. And if attempts is greater than or equal to 5, then break. And that'll just cancel out of the while loop and let you time out. So first we're going to do client socket dot connect. Before we had dot binds, but for this one we're going to be using connect, and it works the exact same way, as in it's expecting an IP address and it's expecting that string above and then a port. So I'm going to make all these variables here private. And before I start my connect quarantine, I'm going to do this dot IP is equal to IP, and this dot port is equal to port. And when you reference this dot IP, you're referencing the one that belongs to the class, because here inside of this function there's already a variable called IP, and you can see when I hover over it, it's linked to this one, and when I hover over this one, it's linked to this. So this is going to attempt to connect to the address. And to handle it failing, we need to surround it with a try and catch. So whenever the connect fails, it's just going to throw an exception. It's just going to throw an error, and we don't want it to cause our application to crash. So if we surround it with try and catch, that will allow the error to be handled. And then once we catch the exception here, we can do debug.log, connection failed, trying again. And here before we connect, we can even say attempting to connect. I can also add in a wait for seconds here. But I can't put it inside of the catch, so I'm gonna have to have a Boolean here for whether it failed. I'll put it outside of the while loop and I'll call it failed equals false. And then put failed equals true if an exception is caught. All right, there we go. So right before we connect, we set the failed flag to false. And if it fails, it will be true. And here we can put if failed. We can wait 3 seconds here if it failed, and then it will try it again. And if it failed and it broke out of the loop here without that failed flag going back to false, then we couldn't connect. We're going to say cannot connect to server. And then we can return here so that the rest of the function doesn't get called. And since we're using a IEnumerator instead of just return to cancel out of it, you got to use yield break. Finally, once we're connected, we can do debug.log client connected, and then we'll set the timeout time to 2000, and this is in milliseconds, and the send timeout. So this will be how long between sending and receiving data, not getting confirmation that it was successful, to just timeout. So I think I can go ahead and actually test this now that we have it working. I just need to drop it here and trigger the connect function. I'm going to open up my client manager. All right, so I'm going to go back inside of Unity, create an empty object, and let me go back to that in case you didn't get it. So I just made a public function here called connect to server. I have a reference to the client, and I just call the connect function on the client that we created earlier, and that automatically has set parameters, or I can customize what IP and port I want to give it. But we'll use the default one that are defined here inside of the method call. So I'm going to go back inside of Unity, create UI button. So this created a button in the bottom left. I'm going to recenter it by changing the position and X to 0. This button, I'm going to rename it by expanding it. So when I created that button, it generated a game object called canvas. And this canvas has 3 components on it that handle its scaling, rendering, and detection for the mouse on certain objects. It also created an event system, and this handles input for the canvas as well from your keyboard, and also for mobile devices if you're using a phone. So I expanded the canvas. I have a button here. I expanded the button and I have a text. And within this text, I have a text component, and I can change this to say joined or connect, sorry. And I go back to the button. I can see there's a list of on-click entries, and if I add to this list on the button, it will allow me to define an object, and then it has a drop-down box for no function. So if I go to my game object that I created earlier, rename it to Client Manager, you can rename it by pressing F2, or you can also rename it here inside of the inspector. I'm going to drag my Client Manager onto this. I'm going to drag my client onto this. And I'm going to drag my client reference into the variable reference for the Client Manager. Next on the button, I'm going to get the Client Manager referenced here and go to the Client Manager and call Connect to Server. So here, these are all functions that are defined inside of that class. I know we didn't define any of these other ones, but these are defined from mono behavior. And so this is Unity events. This is how certain events in Unity are called. And so you define a object, a mono behavior. It has to be a Unity object, so it has to inherit from mono behavior. And then you can view all the components on it. So you can see I had the client on it, I had the client manager, I have a transform, and I have a game object. So I can interact with all the different attributes here from a click of a button. So I can call different functions and such from this button. Right now I'm going to have it listen to client manager dot connect to server. All right, sorry about that. So I'm going to open up the window console. And this is how you view those debug.logs that we were writing.
Before you move on, sorry.
Yeah.
Jennifer says that client doesn't have a class and script client can't be found. Could
You
we just
created both the client and the client manager, and your client
Yes,
called
and they're
client.
both named public class client, public class client manager, and they're saved that way. But when I try to drag them onto the client manager blank object, it tells me can't add script component client because the script class cannot be found.
Can you go to window console and check if you have any errors?
I don't see Windows.
Window on the top, general, console.
Yes, it has errors.
Yeah, so you can double click on the errors and it'll take you to them. I can show you the client script again here. Just let me know where the error is and I can
Says it's
hop to it.
line 63. Oh, I see it.
Yeah, so until all the errors are cleared up, Unity won't be able to recompile and it won't recognize that any scripts have been added. So I'm going to hit play. It says that connection failed and it's trying again. And you can see that Unity freezes here. You can see it freezes for 3 seconds, and that's because we're doing our yield return new wait for seconds 3 inside of a while loop. So this is going to be continuously called, and it's not going to keep on going to the next frame until it's been called.
Okay, so I have a lot of errors, and I have no idea how to fix them. It says there's a non-evocable member socket type stream that cannot be used like a method.
Yeah, I can just copy and paste all I have and put on pastebin. All right, I'm dropping it inside the meeting. And the client manager is pretty straightforward. All right, so let's just make sure we're able to connect. So we have the server running now, and I'm gonna initialize it to run on the same port and IP that we configured on the client. And I hit play here, and it'll show client connected. And it'll show that it received a connection, and the connection type was internetwork as we defined earlier. So that was successful. Now we can actually move on to sending and receiving data between each other. Is everyone up to date with the client? You're able to get it to connect?
I have a question.
Yeah.
Where did you specify the IP and port in Unity? I think I missed that.
The connect function, it's declared here by default, and the client manager just calls it, and it doesn't modify any of the parameters. I think now would be a good time actually to have a break, and we can do the Kahoot as well.
Okay. There's some questions in the chat. Some
Yeah.
people trying to catch up.
I can also post this one on Pastebin as well. Make sure you're running the when your server as well, and you've configured it with the correct IP and port that you used in Unity. We could probably also hard code it as well, since we're going to be using the same IP every single time. And with this system, you're able to connect over the internet as well. So I don't want there to be any confusion because we're connecting just to local network. If the IP that you were using was hooked up to your public IP, I guess if someone here were to open up their port and start up server on their public IP, we would be able to connect to it. So if you go to like what's my IP.com, this is what people will be able to connect to. And if I start a server up on this and open up on the same port that you're going to be connecting to, you'll be able to connect. But that's only if that port is open on my router. And I'll have to go through my router and do something called port forwarding, which allows that port to be opened for a specific client on that router. I'm going to do the Kahoot now, and then we'll take a 10-minute break. And then we'll hop back into the coding and then get the main part of it, which is sending and receiving data. And we're going to be sending and receiving data in bytes, but we're going to be using some C# encoding libraries that allow us to convert bytes to, or strings to bytes. So we'll be able to just use strings, but within it, you're just feeding it bytes, an array of bytes, and then you're receiving an array of bytes and then decoding it. So you can really do a lot of stuff. You can set up like each individual bit manually and have that define logic somehow. Let's say like 2 bytes would be 16 bits. You could have like a whole 4x4 grid defined there with ones and zeros with just 2 bytes. All right. The Kahoot game is live. Let me also find the asset that I was mentioning. I thought they had a website here. Yeah, here we go. So this has a ton of support, and with Pro you're even getting matchmaking. It's pretty good. Also, I don't know if it's the developers of Dark Rift, but there is this other extension called Hazel, which is a lower level open source networking language. And interestingly, it's made by the same person who made Among Us, and says he runs it fine with over 500,000 monthly active users. It's this guy, Wilderf. So it's an interesting find to find that the current Hazel networking implementation is maintained by the Among Us guy.
I think that's gonna be everyone joining.
All right, I'll
Yeah.
start it now. All right, what is real-time networking? Curveball. So what is the main reason you'd use TCP connections over UDP? Do authoritative server relationships prevent cheating? Dang. And for voice data, what network protocol would you use, TCP or UDP? Nice.
Jennifer's killing it.
Yeah. Oh, is this the same question?
Yeah, it looks like it.
Whoops. And what's a window not in Unity? Yeah, unfortunately, file recovery is not a window. Nice, congrats, Kenyon. Sean? Nice, Jennifer. I'll send you the key. I can send it right now inside of Zoom.
That's good.
Yay.
Congrats. All right, guys. I'll see you guys in 10 minutes. I'll be right back. Hello. If anyone still is having trouble, feel free to share your screen and we can try to work through it and fix it up for you.
Yeah,
quick question.
Sorry. You're good. Go ahead.
Quick question. So I have the client running on the terminal, but I'm not seeing the messages. Is there something I need to like run in Unity?
You said you're running the client and the terminal?
Yeah, so like the IP we should use, like all that's running. What should I do in Unity to get the connect messages? Do I need to do anything?
So the server itself should be the one running in the terminal, and then Unity should be the client, right? So
Mhm.
the terminal, you enter the IP and port.
Mhm.
And then in Unity, what we created was the client manager game
Mhm.
object. Attach both components, attach client to it. And then I created a button by right-clicking, create UI
Can you go
button.
back to the client manager? Okay.
Yeah.
Oh,
So,
I see. So in client, I need to put client manager. Okay, that's probably
yeah.
what I missed.
And make sure you have that button that's available inside of the game view.
Okay, yeah, I have the button. So
And the button's linked to the correct function.
Okay, so I link the button to.
Yeah. So hit plus on the on-click list on the button.
Mhm.
And then for the object, drag your client manager game object into it. And then the drop-down should be unlocked and it'll list out all the components on it. You'll go to the client manager component and then connect to server, which is the function that we wrote on the client manager.
Okay, perfect. And then I can just run this.
Yeah, so you'll run Unity and make sure the terminal is running in the background, and you should be able to hit connect. And you'll see in Unity that client connected, and then on the server, you'll see receive
Perfect.
connection.
Yeah, it's working now. Thank you.
Awesome.
Hey. Is there anyone else that needs help getting caught up to this point before we start moving on?
All right, we're gonna start doing the server logic for, we should do receiving data. So first here, we're gonna have our begin accepting. We're gonna also create a private void, call it begin receiving. And this is going to accept as input a socket. And so what we're going to do is call socket.beginReceive. And so we're going to use this version of the constructor, which takes in a byte array as the buffer, an offset of the buffer, and then the size of the buffer. So the buffer is just going to be how big of an array we want max. So I'm going to declare a new array here of 1024 size of bytes, such as an array of bytes with 10,024. And the buffer is just how many bytes max you can send within a message. So I can make this like, I think one time I tried something like that and that worked. So you can make it as long as you need, but I don't think for this we'll be going over 1 kilobyte. So we're gonna begin receiving. It needed an offset. It needs the buffer.length, which is 1024. Socket flags, we'll use socket flags.none. and then it's expecting a receive callback, and then the socket to send it to. So I'm going to make that receive callback, just like I did with the other one, with the accepted connection, where I take a async result. I didn't declare this as a new byte array. So now that we have the reference to the socket that we just received the connection from, we can begin receiving onto that socket. This will initiate the begin receiving and receive callback. Let's write the logic for that. So first we're going to declare a socket, and this is going to be the client socket. And we can cast the result.async state as a socket. So this async state contains the socket that we sent the that should be receiving the message. So what we're doing here, what we need to do first is check if client socket.connected. So if it's false, if it's not connected, then we want to return. And then we're going to write line to console. And console.writeLine and debug.log are the same, but debug.log is for Unity and console.writeLine is for C#, in case you didn't catch on. So we're going to say attempting to receive from disconnected client. Next, we're going to declare a var, and we're going to use the client socket and call end receive. And then I can call begin receiving again with the same socket that we got back. So that will be an infinite loop as well. For every client that disconnects, will have its own loop of begin receiving happening every time. So what is that var received? That's just an integer, and that's how many bytes you've received. And in order to get the actually, it shouldn't be the bytes. It should be an actual. I don't know why it's casting it to that. All right, so yeah, that explains why. So we are receiving an integer. I was a little confused because we weren't getting a bytes array, but this buffer will have to be moved outside of the method and kept here. So we're gonna have an array of bytes called buffer, and we can initialize it as well. So now once we call end receive, the buffer is going to contain all the data inside of it, and received is going to be the amount of bytes within that buffer to count until there's no more data. So what we're going to do here is declare a byte array and call it data received. And we'll call this a new byte and call it received. So we're declaring a new byte array, and the size that we're making it is the amount of bytes that we received. And then we're going to call array.copy. This is a class that takes two arrays and just copies them together. And you can input lengths and starting indexes. So we're going to copy from the buffer to the data received, and the length is going to be received. So now I can write console.writeLine. Receive some bytes. And I can mark how many. So right now we're not going to do anything with this. We're just going to make sure that we can send and receive data. So right now we're on the server and have the receive working. We're going to go on the client now and write the logic for sending data. So all we did here was add in this line here to the end of accepted connection. And then we're creating a infinite loop of beginning receiving for a particular client. All right, going back to Unity, we open up our client. Let's create a public method outside of here called send message. First, we're going to check if client socket dot connected. So if we're not connected, we want to fail and then debug.log, not connected. Next, we're going to get the client socket and call begin send. And it's going to expect a byte array. So we'll create a temporary byte array. And declare and initialize it here. So here I'm declaring a byte array with size 2, and we're declaring it 2 bytes. We're sending it 2 bytes, one that is equal to 5 and one that is equal to 10. So convert.2 bytes can take like a string example, and we can convert the output to a single byte. And you have to be careful because if it's too long, it will result in multiple bytes. So as long as the number is small and the string is small, then you can use that convert.2 bytes. Otherwise, you'll have to convert to an array of bytes instead of an individual byte. So I'm going to begin sending here. I'm going to send the temp array. It's going to start at 0. I'm going to send the temp array.length. Socket flags.none, and then it's going to expect a send callback. And then it needs a connection to the server through our client. So I'm going to create another function called send callback. And this is going to be an iasync result. And so I'm gonna get the socket again. And you can always do this by getting the async state. Right now, we're not gonna do anything except end the send. So we're not looping back, we're just sending it once and then it ends itself. So it doesn't keep on receiving. So I'm gonna go into the client manager and create a public void send message, and I'm just gonna do client.send message. And I should rename my send message to send to server, because send message is a default message in mono behavior. It's a default method. Sorry. All right, so this is all we did on the client side. We can give it a try now in Unity. Let's duplicate our connect button, rename it to connect, and rename the new one to send message. And we're gonna move it upwards. Change the change what we're sending it to send message, the one we wrote before on the client manager. And I'll change the text here to say send message. So I'm going to connect. I'm going to restart the server. So here we received 2 bytes. I don't have any log on the client, but the server here is saying that it's received 2 bytes from the client. So that's awesome. We got messages flowing from the client to the server, and we can basically copy and paste what we have on the client and put on the server. And we'll have messages flowing between the server and the client. So I'm gonna copy what I my send to server.
Real quick, can I see your client manager again? I'm sorry.
Yeah, I don't have that either.
Okay.
Yeah, I just made another method that just points to the send to server.
I'm sorry, I didn't see what goes in the send message function.
In this one,
Yeah, thank you.
I'll also add a debug message here and say sending data. So as I was saying, I can copy and paste this from the client onto the server. And change this to send to client. It will require a socket to send it to. And we're going to do the same thing and change the client socket here to socket. And change my debug.logs to console.writeLine. So what I'm going to do here is every time I receive something from the client, I'm going to automatically send back to the client. So I'm going to have send to client be called in the receive callback. And for the socket, I'm going to provide the client socket. So this should send bit data back to you as soon as you send it to the server. We can also copy the begin receiving from the server and move it to the client.
I'm not sure what we're copying where.
I didn't copy it yet, but we're going to be moving the receiving functionality to the server, from the server to the client. But what we just copied was from the client to the server was the send functionality, where we send data to the server.
Yeah, so the send to server in the client script, copy that over to the server.
Yeah, and rename it to send to client. And we made some changes to accept a socket instead of using the client socket. And then change debug.log to console.writeLine. We also added a function call to the send to client that we just made inside of the receive callback and point it to the client socket so that as soon as we receive a message, it will immediately send it back to the same client that we received the message from. But as we are single threaded, it might make more sense to create a IEnumerator inside of our client here. Once the client is connected, we'll want to start a coroutine and call this receive data. And I'm going to declare a new IEnumerator and call it receive data. I'm going to declare a new byte array and call it buffer and create a new one, and make sure your buffer between the client and the server is correct, is consistent. And then this is going to be an integer for the amount of bytes that we received. So I'm going to create a while loop here, while client socket dot connected, and then we're going to yield return null. So this is just going to be a infinite while loop. As long as we're connected, then receive data will constantly repeat. So what I'm going to check here if client socket dot available is greater than 0, then we're going to perform some logic. Available is it's being received off the socket, and it's an integer that contains the amount of bytes that are available to be read. So if you wanted to query and check if there was anything that needed to be read, that's how you would check it. So now we know how much we know that something needs to be read, so we're going to receive it. So I'm going to call client socket.receive, and it's going to place everything it receives inside of that buffer. Next, I'm gonna declare a new array as I did before. And I'm gonna declare it the same size as received. And I'm gonna do that array.copy from the buffer to data received. And the length is received. So now I can do debug.log received. Alrighty, so I did basically the same thing where I'm receiving off the socket the buffer, and then I'm copying just what we read from the amount of bytes that we received in comparison to the buffer, and then we just copy it onto a new byte array that's the exact size of everything that we received. So now I can go inside of Unity, start my server back up, and I should be able to send a message, and then it will ping me immediately back that I've received a message. There we go. So it said receive some bytes, and then it's sending data. And here I received 2 bytes back. So I can keep on repeating that. This is a bulk of kind of the networking, getting the messages to go back and forth. The next big challenge is getting the events for on disconnect, on join, and things like that. The first step to that is maintaining our list of users that are connected to our server, because right now we don't know who's connected until the accept connection is done, and then we start receiving infinitely on their socket. So what we'd rather do here is create a private dictionary. And for the value, we're going to give it a socket. And for the key, we're going to give it an integer. And we're going to call this connected users. And we're going to declare it as a new dictionary. A dictionary is just like a list, but it has a key value pair. And you key it by just putting, just like regularly indexing an array or a list, but you would index it based on its key value. And then it would output the value. And these are much more faster for indexing and hashing data, where there's only one socket that's going to exist as a key. And they're not going to be the same. So like they're all going to be unique keys. So once we've accepted the connection, what we're going to do is add to our connected users. We're going to add the socket that they got, and we're going to generate a unique user ID. And so we're going to declare this unique user ID as a new random, and we're going to do next. So this is going to pick a random number between 3 and 500. So we're just going to give them that. And we want it to be unique. So what we're going to do is have a while loop and check if while connected users dot values dot exists or dot any. Yeah, so dot any, and press control period, and it'll let you say that you're using the system.link library. If it's still giving you an error, hover over it and it'll let you use that library. So what we're going to check here is while there's any user that contains the same unique ID as the one we just generated, then we're just going to increment it. So what we're doing here is getting just the values, and then we're using link, LINQ, which is a C# library that lets you perform queries on data. So any lists, you can perform this. And then we're creating an anonymous function here. As input, it's accepting X, which is going to be the value that we're comparing to. And we're checking if any value has the same value as unique user ID, then we're just going to increment it. And we're going to do this in a loop until no user has the same unique user ID.
Can you zoom in just a little bit?
Yeah.
Thank you.
And directly referencing your values isn't ideal for dictionaries, but this is a one-time thing where we're just generating a unique ID. So it's okay to go through the values instead of traditionally accessing the values through their key. So this should allow us now to have a dictionary of all the users that have been connected. And I can say received connection and also include the user ID that they got. And when I receive a callback, I can check here what client it belongs to. So I can check client sender equal to connected users. And for the key, it will be the client socket. And so now I can say receive some bytes from client sender. So now to the server, it has a list of all the clients, and now it can find what client is sending it a message. And we can identify them based off a unique key that we give them, that we assign them when we add them. So now if I'm to give this a try and start up my server and load my client and connect, you'll see I received a connection. It generated 239. I can send a message. And you can see I received some bytes from 239, and it was 2 bytes. So that works perfect now. Next, we're gonna try to start sending in a string between the server and the client. So first, we're gonna go back to Unity. Is everyone caught up? This would be a great time to get re-caught up.
I got completely lost when we were copying stuff over, so I'm not sure.
Do you want me to just paste it over? Because we copied some stuff over in various places. Alrighty.
And then for the button in Unity, for the send message button, we would link the on click to the client manager again?
Yeah, the client manager and the send message that we made. So I just sent the client. I'm about to send the server. It is sadly a bunch of copying and pasting because like you have to either memorize all these different calls I have to make, or it's copying and pasting to get the base foundation there. And then using this, you can kind of get to more complex solutions.
How do I tell which button is which? It doesn't like highlight it in the display or anything.
You would have to be in the scene view. And then if you double click on an object in the hierarchy, it will take you to it.
Okay,
So you would
thank
be
you.
able to see it there.
Can you hover over the send message button so I can see the inspector? Yeah, thank you. For some reason, I'm not seeing the send message function.
And you have it inside your client manager as a function here. Public void send message. Public.
I had a similar problem. I wrote out send message, like the whole word message. So I think you have to like have it how he has it, the MSG instead, because they're when
Yeah, I have it like that.
Okay.
Yeah, it looks the
So
same.
no errors, and it doesn't pop up.
Yeah, I'm not seeing any errors in the console.
And it's a public void. Public void send message. I don't know. I don't know what I can tell you. I mean,
Do you want to screen share?
yeah.
Maybe you can look see what your Unity looks like.
Sure. It says host disabled.
Oh.
Oh,
Let's see.
Heather, would you be able to enable that?
Let me check. How is that?
Yeah, I can share now.
All right.
Okay. So I have this here. Console doesn't have any issues, it looks like. I go here. I have it as runtime only client manager, but there's just nothing.
Can you click on your client manager in the hierarchy? Other side. Can we draw on this?
No.
Oh, dang.
Yeah, it's really weird. I don't know why it's saying that. Go to your send message button again.
Mhm.
Click the drop down. It says monoscript. Can you delete your, or go to your connect button and see if it's the same issue? Click the drop down. All right, so that works. Can you click on the no function, the one above it, and remove it?
Oh, this one?
Yeah, just click in the gray. Yeah, so now select the minus button and that'll remove it from it. So that one was just an empty one. Try deleting your send message too. I think it might have gotten messed up when you were duplicating it, if that's what you did.
And just delete it.
Yeah, delete it and duplicate the connect again.
Oh, okay. So just duplicate
Mm-hmm.
and then rename it. Okay, and then I would change this to
Yes, to client manager dot send message. The
This?
MSG.
this
There you
one.
go.
Okay. Awesome. Thank you.
Yeah,
That's really
and you
weird.
just have to move your button again and
Oh,
change
okay.
the
Okay.
text. You should be good.
Okay. Okay, awesome.
Alrighty, nice. All right, so next up, we're going to create a C# script. Call it UI Manager. We're going to open up the script, have a reference to the client manager. We're going to have a public game object for connected panel. And we're going to have another one for unconnected panel. We're going to have a string here for message and make it private. And then I'm going to have a public void here called setMessage, which accepts in a string. I'm going to call it MSG. And so I'm going to do MS message is equal to MSG, or if I did them both the same name like that, I'd have to do this dot message. And then I'm going to have another one called send. And so I'm going to take the client manager dot client dot send to server. And we'll just keep it like that for now. Let's also finally declare our update loop and have an if client manager dot client. We need to check if it's connected or not. And we don't have a public way of doing that. So I need to create a public method inside of our client called public boolean is connected. And this is going to return client socket dot connected. And it's a good idea to update these references to use our is connected function. So that way we're checking our is connected all from one place. And there's also an additional way to check if you're connected, which is to poll it, and you can do client socket.poll. I'm not going to do this just because it's a asynchronous function and then it's going to require another callback. But that'll allow us to poll and check if we're connected and give us a better indicator of whether we're connected. Because I did this maybe two years ago, and I ran into a lot of issues with the is connected function on multiple clients. And after researching it, I came up to that result. And I'll have more resources at the end of the workshop too that you can use as reference. But just to let you know, this is kind of unreliable when you're using it in a different, with more users than like actually using it over the internet. So if client manager dot client dot is connected. Back to the UI manager, we're gonna turn on connected panel dot game object dot set active true. And then we're gonna disable the unconnected panel. Otherwise, if we're not connected, then we want to reverse that and set the control panel to the connected panel to be false and then the unconnected panel to be true. So this is going to allow us to move our connect button and our send message button to be on different panels. And so we can deactivate and activate UI depending on whether you're connected or not. So now we can do that and go to our canvas, right click on the canvas, select UI and create UI panel. A panel will automatically stretch to the whole container. So because I added it to the canvas, it will stretch to the whole canvas. So this panel, I'm going to name this to connected. And then I'm going to duplicate it and call it unconnected. And I'm going to move my send message button to the connected game object panel. And I'm going to move my connect button to the unconnected game object panel. So now you can see as I disable either one, you can see my options for UI change. So I can start them both on or off. I'm going to start with the connected on so that we can continue adding in more functionality to this. Next, I'm going to go to the canvas. I'm going to drop my UI manager to the canvas. I'm going to link my client manager. I'm going to link the connected panel, and I'm going to link the unconnected panel. Now I'm going to start the server up, and we'll just check to see if I'm switching between the different UI correctly. Bam, so I am connected. I can send the message now. I can also turn off my server here. And you can see when I attempt to send data, it will see I'm disconnected. And then that connected will now return false. So now we can't connect. The same thing works on the server here. If I go to the server, actually, since we don't have any way to check if a client's disconnected on the server yet, it won't work. But the server will automatically know when client sockets have been closed, when they're connected is false. And so we can manually remove them from our connected list and manage handling their disconnection. So that's what we're going to do now. So we're going to go to the let's see here. All right, actually it should work. Let's see if we're getting this callback, attempting to receive from disconnected client. All right, so I connected, I ended Unity, and so it should give me a callback here. Yeah, no, it didn't handle it correctly. Established connection was aborted. So what we're going to do is surround the begin receive with a try and catch. And basically every function from sockets have a provide exceptions, and you can use that to handle failures. So when you connect, when you're binding, you can try and catch and see if binding failed for whatever reason and handle any cases for that. But here, if we're receiving and we handle a issue receiving, let's try writing to console that it errored out. I'm going to put client is disconnected. So I'm going to start the server back up. I'm going to attempt connecting again. And disconnecting. All right. Sometimes I have some issues with data not updating until I hit enter in my console. And sometimes it doesn't show that the user actually disconnected until you start Unity back up. So I'll show you that again so we can confirm it's working. So I'll go to the server, start it up, connect, just leave. And we'll see here, it still says received. We haven't checked if they've been disconnected, but now we see here client is disconnected. We can also handle this with our connected users list, and we can do connected users.remove socket. So here I'm added to the right line to also display the ID of the connected user who disconnected. So this is going to go through, get the socket that disconnected, and then remove it from the connected users. So now that's working. We got connections from the server and client. You can abort them at any time, and then they'll be able to graciously handle those cases. Next, we're gonna add in just a chat message, chat log between two users, and then we'll probably be done with the workshop. So I first set up the logic here in the UI manager for set message and send. So let me update the send message to also take in a input of string from the user and then send it to our server as a string. So first I'm gonna move this send message button to the bottom right. So I'm gonna click on the send message button. This will open up its anchor presets. I can move it to the, so click on the bottom right, it will anchor it to the bottom right. And if I set 0, 0, you can see the exact center is at the end of the screen here at the bottom right. If I wanted it to be at the bottom right of the button, I can change the pivot to be X1 and Y0. So this will move the pivot all the way to the bottom right here. So I can change where this pivot is. And if I reset it back to 0, 0, you can see send message appears again. Next, I'll create a input field. I'm going to have it stretch along the bottom. Change the Y pivot to 0. And then when I change the Y position, it'll be perfectly centered on the bottom. I'm going to change the left to 0. And I'm going to change the right to be whatever the width of send message is. So now we have it perfectly aligned. So enter text is exactly right next to send message. Input fields have multiple Unity events like the button does, and you can send an event for on value changed. And if you notice here in the client, we take in a input string. So if you go back to Unity and see on value changed and drag your UI manager on here, you'll see set message is part of the variables under dynamic string. You don't want the one under static parameters, because that one would be this one, and it's asking you to input a string, versus dynamic string will automatically set the input to be whatever the text input is. So whatever we get back inside of our UI manager set message is going to be the whatever message is here. Uh-oh. I don't even know what I did. I think I made a new desktop. Uh-oh.
You had 4 different desktops.
I got, it's a regular button. All right, so the send message, I need to update it to go from the client manager to the UI manager. And I'm realizing how useless the client manager is gonna kind of becoming, but you would use it kind of for handling when the client disconnects, when the client connects, and whatnot. But since we're moving the functionality to the UI manager, the client manager kind of isn't needed. So I'm going to change the send message to the send, but I'm going to keep that connect link to the client manager. I may as well. So now I have to update our send functionality, because right now we can only send to the server and we can't send anything custom. So I'm going to send to the server just message. And I'm going to accept message here. And I can use the encoding library within system.txt and use utf.8.getBytes, and I can input a message here. So I'm getting rid of my old system where I manually made the message that we're sending 2 bytes and turned it into a byte array that's being received from this function getBytes, which accepts our message. So I'm going to update our send to log and also include the message that we're sending. So now I have to go to our server as well. On our receive callback, we're not doing anything with the data that we received. So if we wanted to see what message we got, we would get string message received is equal to encoding UTF-8 and should be get string. And it's going to accept that. All right. So this is how we're getting the string back from the bytes. So we're doing get bytes, and it returns a byte array, and then we do get string with the byte array that it gave us on the server. So we're able to convert what we got from the client back to a string. And we have to do the same thing here for send to client, we're not going to do it right now, actually. Because then I would have to update the receive callback on the client. But for now, I'm just going to have it send in a string to the server, and the string should display it in its console. And I'm going to delete the send message from client manager. Spin up a new server. So I'm going to send hi, sending to server hi, and receive some bytes from 277 hi. So now we have actual strings being sent back and forth from a server, or from a client to a server. Is anyone having trouble getting this?
Yes. Sorry, I have so much trouble. I think I got lost on the client manager.
Yeah, I got lost on the client a bit as well after you did the encoding UTF-8. That's kind of where I got lost.
Alrighty. For right here. We just, for the client here, I changed the send to server to accept a string. And then here, instead of the temporary equal new byte 2, and then byte 0 equals whatever, byte 1 equals whatever, I'm setting it to equal UTF-8.getBytes message. And then I update the log to just display the message we're sending, and then that's it. And it should handle it from there because it's just sending the bytes over.
I'm getting an error that says there is no argument given that corresponds to the required formal parameter message in the client manager.
Did you get rid of the send message?
No. So it should say client. Oh, just get rid of that function altogether.
Yeah, we moved the functionality to the UI manager, which also allowed us to get an input message from the input field.
Okay. Okay, I'm still getting an error. It says the name encoding doesn't exist.
Can you highlight over it and see if it's prompting you to import any libraries? It
Yeah,
should
it's
require
not.
to use using system.txt. That should be at the top of client if it's missing.
It's not highlighting it, but I'll add system.txt and that should.
I'll show you on my screen as well what I mean by the highlighting. I'll get rid of using system.txt. And if there's any references that are missing,
Right, it didn't underline it for some reason.
you should be able to select quick refactor and using system.txt.
And then can I see on Unity what you did for the send message button?
Yeah, I just updated the send message button to use the UI manager.send.
Okay, and then how did you get it in the correct corner?
You want to use the anchor tool, anchor presets. Select the bottom right and change the pivot to be on the right by setting X to 1 and then the Y to 0. So that would be on the bottom right. And then setting position X and Y to 0, and then it should reset it to the exact bottom right.
Okay, awesome. And then how do I fix input field?
Input field, you'll use a stretch along the width, and then for left 0 and right will be the width of your send message button, which should be 160 by default. And pivot Y0 and position Y0 so it's at the exact bottom, like the send message.
Okay, perfect. Thank you.
Finally, the on value changed. I don't know if you added that to the input field. On value change needs a add to UI manager dot set message, and the one at the top, not the static parameters one, the ones in the dynamic string list.
Okay. Okay, so when I run the server and then I run Unity, I should be able to type in it and see it, right?
Yeah, you should be able to see it from the server if you updated the server's receive functionality to decode that string.
Okay, yeah, I'm not getting the decoding.
Can you share your screen? All right, scroll down inside of your server scripts. Should be
Sorry, where do I go?
program.cs, right? Program.cs.
Oh, yeah.
Weird. So is Unity and your server also in the same project?
They should be. I mean, everything's worked so far.
All right. Yeah, it's odd that it works if they're the same project. Receive callback. You hit the send button as well? Can I see inside of Unity?
Oh, I have to hit the send button. Okay, let me try running that again.
It doesn't look like your send button is sending anything from Unity.
Yeah, it's not.
Is it hooked up to the UI manager?
One sec.
Yeah, so click on that and click the drop down, UI manager, and you want to use the one at the, oh, that's the set message. You want send message. You want the function that calls it to send. I don't know what you called it. Can you open up your UI manager? Your UI manager script?
Yeah.
Yeah, create another create another function in there called public void send message, or just call it send. And then call client manager dot client. Exit out of hit the red exit play button on Visual Studio. All right. Now press period, and it should be send to server, right? I don't know why autocomplete isn't working either. And it's going to accept a message in the parentheses. There. Now you should be able to... No. It's going to be using message from the class, not that we send it. So there you go. Save that, and it should work once you update the send message button. And I also want to make sure your input field works. Go to your input field too. Scroll down a bit. Nice, so that should be working. Try it again.
Okay, awesome.
Nice. Yeah, you're getting the message hello. All right, I'm gonna share my screen again. Great, so now we got messages going from the client to the server. Now let's go from the server to the client. So I'm gonna go to the send to client here. And I'm gonna accept a string message. And we're gonna do the same thing where we use the encoding.utf8 get bytes message. And then I'll get rid of those other ones. So here I'm going to update the receive callback and add a send to client welcome. So I'm just going to send welcome once a user connects. So all we did was add this, and this part to the server. Next, I'm going to update the client's receive function. And I'm going to do what I did with the server here, where I have message received is equal to encoding.utf8.getString. So I'm going to go back to the client and set string message received is equal to encoding.utf8 get string from data received. So we're going to say receive from server, and we're going to say message received from the server is that. So now I'll give it another go. Start up my server. And now try connecting. Oh, sorry, this would only be called back once you send something, not when you join. Yeah, so I'm receiving back from the server welcome as intended. And I can always add from the server here, I can, I'll get rid of this send to client and move this to accepted connection. So when we accept a new connection, I'm just gonna try sending it back its unique user ID and convert it to a string. So when you connect to the server from the client, you'll get back the user ID that the server generated for you. So here I see I received back 28 as soon as I joined, and that was the ID that was generated for me. So this works really good, and we're able to send a custom message to the server from the client. But now we want to have like a chat log pop up, and we can do that by broadcasting one message from one client to all the other clients that are connected. And so let's first create the UI that we need inside of Unity for it. I'm going to create a new UI image. I'm going to have it attached to the bottom left with the pivot point X0 and Y0. So this is going to be at the very bottom left. For the Y position, I'm going to set 30. And for the width, I'm going to set, let's say 400. I'm going to rename this to text box holder and add in a vertical layout group. I'm going to change control child size and allow width. And then I'm going to create a actually right click connected, create UI scroll view. Copy the rect transform from text box holder. So we're going to make this, instead of being a single box, it's going to be scrollable. And we can do that by using the scroll view that we just created by going to UI scroll view. So this will create a scroll view, and then we want it as a child of connected. And we're going to copy the transform from text box holder and paste it to scroll view. So this is going to resize scroll view to be the same size as that image that we made earlier. I'm going to disable horizontal for the scroll view because we only want to move up and down. I'm going to delete the horizontal scroll bar. And next, you can see visually this scroll bar doesn't go down because it thinks that the horizontal one is still there. So you have to go to the scroll view and just toggle on and off the scroll rect. Just toggle it off and on, and then it should update the scroll bar vertical and disable locking on the bottom. So you'll be able to set it back to 0. So here I can create, to show you how the scroll actually works. This is how it would be working. You just determine, you just give it a height, and then it will render out this content. So if I decrease the height here, you can see that scroll bar getting smaller, and as I increase it, it gets bigger. So that works pretty well, but it doesn't resize according to what's inside of it. And what we want inside of it is going to be UI text. So right click the content, create UI text. Go to the content and add the layout group. Child and alignment, use lower left, and then, as I said earlier, control child width. We also want to use a content size fitter, and we want to add this to the content object. And for vertical fit, we're going to use preferred size. So this will automatically resize content to be the same size as text. So as I increase the size of text, content will change its size with it. So you can see it's no longer editable, and vertical size is automatically set. But I want the text to automatically get bigger as I add more text. To do that, I also have to add the content size fitter and add a preferred size, and it will automatically resize to the preferred size of the text. So now I can keep on adding more and more text to it, and then it automatically allows the scroll bar to get bigger and bigger, and then you can scroll through it. So now we technically have chat working. I'm gonna move it to the bottom instead of the top. And in order to do that, you want to change the pivot on the content from 1 to 0. So that's going to be where it starts adding in the content. So if I were to duplicate these, I can also add in like as much content as I wanted. But for the sake of the workshop, we're only going to have one text instead of creating a new text object for each text message, like you might do, depending on how your UI is set up. Finally, I'm going to add some padding to the text. So I'm going to go to the vertical layout group, expand the padding dropdown, and add in 10 pixels of padding in every direction. Next, I'm going to go to my UI manager, select Edit, and go to add in a new variable called public text. And that will require the using Unity engine.ui. So you'll have to be using that, otherwise it'll throw you an error. And I'll call this chat log text. So we need to reference the chat log text and somehow add what we are receiving from the client to the UI manager. So I'm going to create a simple callback on the client manager here. Actually, I'll add it to the client. So we'll scroll up to the top of the client, create a private delegate void on received message. So I have to make sure both are public. So I added these two variables to the client. A delegate allows you to listen in on a event, and then you can invoke that event at any time, and then all the listeners will get notified of that. So how that's going to work is here on connected to server, I can add actually here to the UI manager, void start. I can go to the client manager, .client, on received message, plus equals received message. And then I'm gonna create received message, and it accepts a string. So what I'm gonna do is grab the text from the chat log text, and I can set it to whatever I want, and that will update the UI to be whatever I wanted. So what I'm going to do is just add on to the text. I'm going to do chatlog.text plus equals. I'm just going to take whatever is there. I'm going to add on to it a new line and then the new message that we got. So this was all that we added to the UI manager, a reference to the text. On start, we are going to start listening for when we receive a message, and then when we receive a message, we'll replace the chat log text. Now I actually have to update this so that we call the function when we receive a message. And so I'll do onReceive message and invoke it. So that means everything listening to this delegate will get called. So I'm listening to it by adding plus equals, and if I wanted to unlisten to it, I can do minus equals. So I'm just gonna listen to it from the beginning, and every time received message gets called, this will get called here, and the chat log will get bigger. So now I can test that, and it should work once I connect and display welcome. So I'm on my Canvas UI manager, and I have to drag the text that we created that says WDDWD, move it down here to chat log text, and hit play. Now if I go to my server, start up my server again, connect in Unity, you can see here I'm getting my ID 171, but I'm not actually clearing the log from the client. Let me do that here. I'll leave chat log.text is equal to nothing. So there we go. So it's sending back message 487. And I can send messages to it, and it doesn't send back a message immediately. But that is what is next to propagate the message to all the clients. Now, is there anyone stuck? This is going to be the last step of sending data back and forth, and this should be the end of the workshop pretty soon.
Yeah. I tried to follow along with what was going on in Unity, and it's just going by really quick, and I didn't get the UI manager, I think, done. I don't know.
Yeah, the scroll view, if you're having issues with it scrolling and everything working correctly.
I mean, I don't know if I have all the components in there. I tried to follow, but it's fast, so.
Yeah, you don't need any of the scroll view components. You just need a text at the end of the day. So just create a text. We'll set the
I
width.
have scroll view. I don't know what I need in it.
Yeah, you just need text, and there's a bunch of steps with getting the scroll view to respond to the size of the text. So we're just going to create a text here that works as a sample of viewing our log here.
I should delete what I have then?
Yes.
Okay. So then what do I do then?
Create a new text and set the width and height to the width to 400 and the height to 250, and that's it.
Wait, do I need to create scroll view first and then put text?
No, you
in
don't.
that?
You don't need a text. You don't need a scroll view. You can get rid of scroll
so
view.
just UI text.
Just UI
If
text.
you're connected.
Yeah.
Okay.
Next, go to the UI manager, and this is what we added to the UI manager.
Okay, chatlog text dot text. Okay, so that's just an empty string, and then I have a okay. I have that.
You have this method as well, the received message.
Yes.
Great.
Yeah,
And you
I have that.
updated the client as well to have these two?
Yeah, I created the member variables for the fields delegate void. Yeah.
And you invoke it at the when you receive data?
Let's see. No, I do not. Okay, so on. Okay, I have that now.
Alrighty. Now go back into Unity and go to
Mhm.
your UI manager and make sure the chat log text has a reference to the new text that you just made.
Okay, wait, I go to Canvas?
Yeah, to your UI manager. And you want to
Okay,
make
yeah,
sure
that's not updated.
it's assigned.
I have.
Yeah, you'll have to drag in the text that you just created because you just made it. And then you have to add it as a reference.
Wait,
Does
how do I
just
do
dragging it
that?
in work? Just drag in the object from the hierarchy window.
No, I don't have a chat log text field in the UI manager script.
Are you
It's
getting
just not
errors?
there. Yes. It says it's on the client CS.
And what's the error?
Inconsistent accessibility field type client on received message.
Make sure both the values here are public at the client at the top.
Oh, okay, one of them is private. Oh, that created more errors.
What are the other errors?
So it's still saying, okay, so it cannot, here, I'll just share my screen.
Yeah, I'll switch over.
So it's
All
saying,
right, double click that error on the UI manager. All right, so you want to use the lowercase on receive message. All right, give it a save and try it again. Cannot, yeah, double click that. All right, on line 26 where you're doing chat log text plus equals, you want to do chat log text dot text plus equals.
like that?
Yes. There you go. And now you can save it.
Okay.
Nice.
So then I go to the okay, so then I put this reference here.
Mm-hmm.
Okay.
And then it should be working now once you connect to this server.
Okay.
Is the connect button still hooked up to your method? It should be the disabled button under unconnected where it says connect. Yeah, so it's still saying connect to server. When you click on it, nothing happens.
No.
Oh, text is covering up the button. Move text to the top of the to the top there. Yeah. So
Okay.
there you go. Yeah. Unity decides what's clickable based on its order in the hierarchy.
Okay, am I supposed to receive a message from somewhere?
It depends because we changed a lot of the server. Go back to your server. All right, so on the accepted, scroll down, accepted connection method. You should be calling
Or where? Sorry.
Yeah, the server isn't updated. I'll go through the server again and the changes I made. Here, I'll share my screen.
Okay.
All right, so the first change we made was here in the send to client. We added a option here, parameter for message. Next, we have a inner temp array. We do the exact same thing as we did before, but instead of declaring it as new byte 2, we do encoding.utf8.getBytes. And that's all the update that we did to the send to client. You'll have to update your send to client method as well. And I think it might be in your receive callback. You'll have to delete it from the receive callback.
Yeah, I deleted it there.
All right, and now add it to the accepted connection. And right before you begin accepting again, you'll send to client socket, and then for the message, you'll give it just its unique ID that you generated.
And that's all I need to do to change the client.
The server, yeah. So once you
Server,
start
sorry.
the server up and connect through the client, you should get a message with the ID in your chat log.
Okay. Yeah, I'm still not seeing anything.
All right, I'll hop over to your screen again.
Am I sharing my screen?
Yeah.
Okay.
Double click on that received bytes 3 log in your console. Double click on it. Does it open? Okay.
Can you see?
Yeah. I don't know why it's going to that line. Go back to Unity so I can see what line it's coming from. You see the bottom text at the bottom of the console that says asset/script/client. Yeah, click on that one. Okay, weird. It keeps taking its top. It says it's line 118. Can you scroll to 118?
Okay.
Unreceived. Instead of received bytes, add message received. And then instead of received, use the message received variable. And save. And also go back to your UI manager. I just want to make sure you're listening to the unreceived message. Yeah, okay, good. Yeah, give it another try. Can you expand your text object in the inspector?
How,
In the
this?
inspector? And the one with the rect transform and the text on the right hand
Yeah,
side?
click on the little arrow next to text on the
On the very
right.
right, on the very right window, on the inspector window.
Oh, sorry, it's a little. I got all the Zoom stuff. Okay,
No, good,
this
okay.
here.
Yes, but below where it says text, where it has the text component.
Mm-hmm.
Yeah, so it's saying Oh, you didn't set the height to 400, 300, 300. Change the height to the width to 400. Width, height to 300.
Like that. Here, 400.
Yeah, I don't see it in the world at all though.
Okay.
Can you make it a child of connected? All right, perfect. Save and try it again. Because it's actually getting it, it's just not showing up in the UI. There you go.
Okay, yeah, I see it here.
Yeah, so it works. Nice.
Thank you for going over that again. I was missing some stuff in there too.
Mhm.
Very
Of
helpful.
course. All right, I'll share my screen again. So now we want to propagate the message from the client to all the other clients from the server. And we're gonna also add in a way of creating a header that is an integer. And we can, using that header, we can do different things with the data. So it'll make more sense once we're on the server side, but for the client, we're gonna add in an extra byte to the message at the beginning, and that's gonna be our header. So we're gonna call this int header. Actually, at the top sent to server, we're gonna call it int header. So we're gonna have a header and a message that the sent to server takes. So first we're gonna have byte data array is equal to new byte temp array dot length plus 1. So what we're doing here is creating a new byte array, calling it byte array, and setting it to be 1 greater than the temp array size. And then at byte array 0, we're going to set it equal to convert dot 2 bytes, and we're going to convert the header to a byte. Next, we're going to do the array.copy so that we copy everything from temp array back into data array, but it has to be skipped from the first entry. So we're going to go from temp array to data array as our destination. The length is going to be temp array.length. And it also lets you set an index to start off at. So we're going to copy it from the first value in temp array to the second value in data array. So this basically means we're copying from the start of temp array all the way, we're copying the start of temp array to data array after the first index. And so now if I send data array instead of temp array, it's going to contain that extra header in its message. All right, so now that we have this, where we're getting the first entry inside of the array to be equal to our header, now on the server, when we decode this, put this on the side, So we have the send to server and then receive callback. So here, instead of getting string from data received, we will have to declare a new byte here, and this is message data, and this is equal to new byte data received dot length -1. So here we're doing the reverse. So before we were adding one to the data to get the full message. Now we're going to do the reverse and get the message data as separate bytes. And we're going to start that from 1 less than the amount of data that we received, because the header is going to be at the beginning. So we can easily get the header right now by doing int header is equal to convert dot to int or right. Header is actually just going to be a byte, and it's going to be equal to an integer. So I can set this as header is equal to data received 0. Next, we want to finish copying our message data. Sorry for jumping around here. So we're going to copy from the data received from the beginning, or from data received from the first one, after the first one, and we're going to copy it to message data at the beginning. And the length is going to be message data dot length, which is going to be 1 less than what we're getting. So now if we want to decode what message we got, we have to do message received is equal to encoding.getString message data. And so now we can ignore data received because now we've gotten everything that we needed from it. We got the header at the beginning, and then we got the message that came after the first byte. So I'm going to change this received from client sender. I'm going to include the header, and then I'm going to add a dash. So when we get our information back, it's just going to say received from the client sender. This was the header that they gave us, and this is the message. Let me go back to the server. So does this make sense? We're adding a extra byte to our message and then adding it as the header. And then when we receive it, we try and decode the first byte that we got back and use that as the header. And then we get the message received back as well. In order to test this, we can go to our UI manager and send to server. We can identify, let's say 10, header 10 as being a chat message. So we're changing our send to server from our chat message to send with the header 10. So this means on the server, we're going to get back every time we send a chat message, it's going to say back 10. So I'm going to start my server up. connecting. You can see here I haven't received any information, so I'm going to send hi, send it. And so here you see received from 46, ID 10, hi. Currently on the server, there's no way of, let's see here. On the client, there's no way of receiving back a header, and the server, there's no way of sending us a header. We'll get into that one next up, but here, once we receive the information, we can create our logic to handle it. So if header is equal to 0, we can do something, else if header is equal to 10, which is what we have in our example, we can do something. And so what we're going to do when the header is 10, we're going to go through for each var user in connected users. So what this is going to do is create a, for each value inside of connected users, it's going to create a temporary variable called user. And this variable type is a key value pair, and it should be a socket and an int. So this is going to go through for each user's socket and integer inside of connected users. We're going to be able to do something. I'm just going to use var. Actually, I'll keep it fully typed out, but you don't need to keep it fully typed out. It'll work the same. So if header is equal to 10, what we're going to do is send a message to every single client. And we're going to send it to their socket, and the message we're going to send is message received. So we're just going to relay message. So right there, once any other client is connected to our server, they will get the message back. And this also means that the client that sent it is going to get the message back. I think this is all that I added. So it should be ready to test out. All right, so created the server, connect, and say hello. It will send back hello because it was told to broadcast it to all the users. Finally, we're going to add in headers from the client to the user, and then give it, try building our game and seeing what happens. So first go to the client, and I'll keep both our server and client open so we can have them side by side. So as I said, when we send to the client, we also want to include a header. We can copy the logic more or less. So we get our temp array here. Then we want to copy this part. And so this will separate it into the header, and this will separate it also into our message. So now send to client is going to be expecting a header. So we can set it to 9, for example. And this header, I should mention, it is limited from 0 to 255 because it is a single byte. You could do more stuff where your header is like a whole struct, and then you're serializing that struct into a byte array, and then you can send the whole struct over with all its information serialized as bytes. But for now, we're just using strings and the header as a single byte. But this, having the concept of being able to transport bytes and being able to designates a certain number of bytes to a specific message or a specific action is important for driving server client logic. I just added the send to client. I added support for a header from the server. Now I need to add support to the client to just read back the header and also read back the message. So here I can copy and paste the logic I had for the receive callback. So I have the data received byte here, byte array, and I copy the data received to that. I want to grab the bytes now. So I'm going to copy that there and change data received to message data here to get string from message data. So now I'm going to also include the header that we received from the server and add it on here. So we received from the server, the header, and then the message received. All right, I'm going to give it a test. See if it works. Builders. So this send to client, I never added a header for the ID that we send. So I'm just going to set it to 0 for now. And I'm going to start up my server. Start up my client. So here it's saying we received from server. And it's saying 50. That doesn't seem right. I'm going to try the server again. Really weird. It's saying that the header is 50. Am I doing the int conversion wrong? All right, I'm going to try that. So it keeps saying that the header received from the client is 50. I wonder if I even update this. Yeah, no. So on the server, I wasn't updating the data that I send over. So it was only sending the message, and then for the first letter, it was just getting back the first letter, I guess, from the message and trying to read it as a header. So now that I'm using data array, that should be okay, and I should be able to change this back to 0. Or let's see here, this one. So once a client is accepted, send to client 0, and we updated the begin send to use the data array instead of the temp array. So now I'm going to start my server up. Try it again. Connect, and I can see here received from server 0 273, and I can say hello. And I see from the server I got back header 9 with the message hi. I can also check here if it seems like when I disconnect, it's saying that it's trying to receive data, but there's no data in there. So I'm gonna try if received is less than or equal to 0, then just return. Or actually just begin receiving again and return. So that should fix up that error that I was getting when I exit out of Unity without the server closing. Finally, I'm going to add in one extra piece here, and this is just to keep track of what user you're in, what user you are. So I'm going to create a new text there, change my pivot to the top left, and I'm just going to add 10, -10, so it's straight on the top left. And this is going to display our user ID. And for example, I'll just put 999. I can rename the text to user ID too. And if I go to my UI manager, create a new entry for text and call it user ID text. Next, I'll go to my onReceived message. I'm going to copy and paste that and call it onReceived ID, onReceived user ID. And I'm going to replace onReceived message with that and change it onReceived user ID. Instead of an integer, I'm going to make it a string. So I'm going to go through and find where I'm doing onReceive message and invoking it. And I'm going to check if header is equal to 0, else if header is equal to 9, then onReceive message. And instead of onReceive message, we're going to do onReceive user ID. And for the user ID, we're just going to put in message received, because message received will be our user ID. So here we're just defining what the different values, what the different message received we got are based on header. And this is just an arbitrary value that we're setting right now. I just randomly picked random numbers for the headers, and you can do whatever numbers you want as long as they match between the client and the server, and logically it makes sense. So now I'm going to go to the UI manager again. Also listen onto onReceived user ID and create a new method called received user ID. Copy and paste it from received message, and we can do user ID text dot text is equal to user ID plus message. Now I go back into Unity and my UI manager, update the user ID text reference on the UI manager. Now if I give it a try, it should rename me according to what I got from the server. Hit connect. So it says user 262. So here we're seeing received connection. We sent back our user ID. We could probably change this sending data log to be more descriptive. We received from 262 hello, and we're relaying the chat message to all clients. And you can see here we received from server hello. And this is header 9, so you can tell it went through and got relayed back as through header 9. And I'm going to do a build and show you multiple clients being connected at the same time. So I'm going to go to where I put this, workshops. I'm going to create a folder called build and build it there. In the meantime, I'm going to get a GitHub page ready as well. I'll just create a new repository. I'm going to make all the code accessible as well. All right, it looks like it built. Let's start our server up. Oh, let me also configure my build because it's just going to go into full screen. We don't want that. I think I broke Unity building. I'll just ignore that. So here, instead of full screen mode, use windowed. When you go to File, Build Settings, this is how you build your game. We selected PC Windows, and we're gonna build. But you want to change your player settings and get rid of windowed here. And I'm gonna make the window very small. And make it 500 by 400. Actually, I need it kind of big for the text. All right, that should work now. My computer froze. All right, so here we have the end product. We have a server and 2 clients. So I'm going to connect from client A, client B, and I can see left-hand side has 482, right-hand side has 65. I can say hello. And then I can say hi there from this one. You can see it doesn't get updated in the next one until I actually make it focused. This is in player settings. You also want to enable run in background. This is essential that every networked game runs in the background. Otherwise, there's some issues where it just won't get the packets, and then it's going to be a sudden influx of data, and it won't know what to do with it. So here I can just send information back and forth. Just make sure you got to update each one. But since I made that change, it should work now with the new build. I'm going to get the repository up. Bam, so it's working now live and it doesn't need to be refreshed. So there we go. We got real-time networking working on a TCP socket connection. I'm going to be posting these slides as well. Let me go through our presentation and actually complete it. All right, so connecting via the internet instead of local access network. As I said, this is kind of like an overview of how the connection would look. You would have one router and another router, and then they would be connected through internet. And then you would be able to reference one computer using its IP address, and then the other computer using its other IP address. So the client would connect to the server using its public IP address on whatever computer it's hosted, and connect using the port that was set up for the application. And the port is arbitrary. As I said, I don't know if I said it was arbitrary. It can be anything you pick as long as it's 5 digits, I think. So anything that you want. And there's some exclusive ones, like 80, for example, is used for HTTPS. And then 22 for FTP and stuff like that. But for the most part, anything over like 1,000 is free reign. So revisiting the complete game server architecture, what we just did is a game server and a client communicating to each other, and that would be for a single instance. But what if we wanted for the user to have their own account and for them to also have their own score and kills and death counter? What we would do is host that on a database, and then the client would communicate to an API asking for that information. The API would send it back, and then it would be able to get its lifetime score, kills, and deaths. And then once it joins a game, the game will then keep its internal track of score, kill, and death count within that game. And once the match ends, it will apply the match settings to their database entry. So once the match ends, their lifetime score will change based on the match results. And this can be done through a direct connection to the database server. And you can even host the database on the same server itself. And the database doesn't even need to be like a actual database server. It can be a text file that just keeps track of every single user's username and password. And if you wanted to use that text file to parse it and find users' information, you can do that. But it's recommended to use like MySQL or a database system for managing data, because it's just going to be a lot quicker and all that. And it's just going to be more reliable when you're dealing with a ton of data. So database server is just a place that's keeping its own local copy of data, of information. And then that's always being stored, and that can persist after the match. So everything that the game server would interact with would just be things that are related to the current match. It would be like what kind of game state we're at, whether we're in the lobby, in match, or match ended. And there's also, it's common to use a database to keep a list of all your game servers. So what you would do is have a database with your game servers, and you'd have an entry for an IP and port, and then name for the server. So this would allow you to create a server list, and you can list out all the servers that are in your database. And then when a user connects to it, it would just connect using the IP and port that it has on the database itself. And you would be able to constantly have an open list of servers that people can query for, and then connect using the stored IP and port. There's some more stuff in here that I wrote. So there's also this thing called, I can't see it because Zoom's in the way, but master server, it lets you, okay, I got it. So whenever a user joins, this would be like a server that every user joins as soon as they open up your game. And then when they close the game, it would automatically just disconnect them from it. And this is sometimes common, not really as common in like action games and stuff like that. But for RPGs, you're typically connected to a master server, and then you have a constant connection to this server, which you can use for providing matchmaking, which will take a user. Let's say the user sends like the header 5 and asks to be put into matchmaking. It'll track that client and track what matches are currently open and place them into a match. And it'll like send an IP and port back and then tell the user to connect there.
As a quick question, if you were wanting to kind of connect a game to a web application or something like that, would you make some sort of like, sorry, would you make like the API calls in the game server?
Yeah, you would make the, well, if you're dealing with the, sorry, can you repeat that? You said if you're sending.
Sorry, yeah. So if,
data from
as an
API
example, this
request.
thing we built in Unity, say we want this to also display on the web, as an example, would I be doing that in the server that we built here? That we would connect it up to a database that would store the strings via some API calls?
Yes, exactly. Yeah, exactly that. So you would host all the data would be hosted on the database server, and then the web server would act as providing that data based off API calls. But if you mean exporting your Unity client directly into a website, then you would have to do other stuff, because what you're doing with an API request is sending a network request. So you're going to be calling like api.example.com/do something and then giving it information in that HTTP request, and then it'll send back data. So it'll be a separate network request than what we've been doing with TCP. Does that make sense?
Makes sense.
Cool.
Hyun also had a question. He said, if I wanted to use this across the internet, would I need to use something like LogMe and Hamachi?
So LogMe and Hamachi, what it doesn't require you to open up a port. It will, it like sets up a separate server that hosts its own port, and then it communicates traffic through that server. So it hosts what's called a relay server, and the relay server, all it does is just relay data from one place to another. And that's useful because you don't want your users to have to port forward. It's a complicated task and requires you to restart your router. And that would be every single time your IP changes, you'd have to report forward. So that means opening up your router to a specific port. So you would be able to avoid LogMe and Hamachi if you port forward and then are able to connect directly to that IP and port if it's publicly available. You could host a Linux build or a Linux server on AWS or like Google Cloud or whatever, as long as it's like a Linux server. You can host your server if you built it as a headless Linux build, tell it what IP and port to connect, and then you can connect to it if that port's been opened in AWS or whatever you're using to drive your Linux server. I have some more examples here of things that I made before. I have a networking demo video that I wanted to show, and I have this GitHub link with it's nearly exactly what we went over here, but with more support added with messaging so that you can create your own messages and define what header it should receive. And then you can process additional logic there. It also sends what client a specific message came from, and also handles syncing every within a certain time step. So like if you wanted to sync your game every 128 milliseconds, you could create an infinite loop that just sends data every 128 milliseconds, and you would send whatever data needs to be sent in that time. So this is something I made here, and I go over configuring my server here. So this is running on a Linux server. So I'm running a IP. Oh wait, this is the wrong one. Yeah, so this is an example of it connecting using DigitalOcean. So I have a Linux server here running, and then I execute the server. And you have to use a thing called mono to execute an exe, because once you build your server console, it's going to execute to an exe. And using mono, you're able to install that on Linux, and it can run C#. It'll be able to run your C# code. So here I have another server spinning up, and this is going to be a individual play server. So I set up my master server before, and now this is going to be a play server. So what my play server does, it'll automatically connect to the master server, and the master server will make a indication that there's a new play server available, and it keeps a list of all the play servers that are available. And then it can communicate to the play server and see what state it's at and how many players are in it. So you would be able to see if the game server is currently being played or if it's still in lobby. And then I have a simple authentication system here. So once you log in, you're just connected to the master server. And then the master server keeps track of a list of users all connected there. So all this data that's happening behind the scene, behind a real-time connection is all database. So this all this information is being saved to a database and your login and authentication database. And then once you actually go towards playing the game, you'll be put into a different server, which will be the authentication server. There we go. So yeah, I have that also added to my Dropbox or GitHub here. If you guys want to check out the source code behind it. And thank you for attending. I have a feedback form if anyone's interested in submitting any feedback.
I also linked it in the chat for you guys to fill out. Hune had another question. He said, "Is there any chance we could see a demo of online connection between two users?"
Right now, yes, maybe. I can try opening up my port, maybe. All right, so I'm going to open up port to networking workshop. You'll want to get your local IP address, which is right, and then the port that you want to open up. So I'm just going to open up 25565. All right, this is my IP. I'm going to start up a new server on that IP, and you guys should be able to connect to my server, God willing. Let me update my code. Put it back to console.read line. Uh-oh. Huh. The requested address is not valid in its context. Oh my God. Ah. I need to make sure it's actually being able to read the IP. I'm thinking it's copying that new line. It's not liking it. All right, give it a shot. Should be working. I'll post my IP in chat.
Is there anything we have to update on our end before trying to connect to you?
Just use that IP. Make sure you're using that IP address in your connection request, and it should be the same port.
I had a connection failed, but I don't know if I'm doing it right.
You're using the IP, right?
Yeah.
Wonder if anyone else is able to. Let me try my own client to connect to it.
Yeah, do that.
Yeah, I can connect.
Nice. So basically what you just went over is how you would set this up to be able to get multiple users from different IPs to join in the server.
Yeah, this would allow you to have different people on a different network to connect to your server, and then your server will be able to listen to and transfer data between them. It seems like when I was opening it originally, I was using my public IP address, but you're supposed to use your local IP address, and then your router is supposed to port forward it to your specific computer. So if I try accessing this IP address, and go to this port, my router will try to find what port is assigned here based off the firewall here. So since my personal computer on this local network, its IP is 192.168.022, that's going to be my personal computer, and it'll try to find what IP to route traffic from this port to. And it seems to be working because even when I try to test the port forward, you can see it will trigger a connection. See here? Yes, the client will be put onto GitHub. I'm actually trying to do that in the moment right now.
Yeah, we can probably post that in the GDK server once it's up and running.
Yes, that would be a good idea.
Was there anything else you wanted to go over? Is there any other questions? My gosh, upstairs.
Right. Yeah, if anyone has any more questions, this is the end of the workshop. I'm going to be posting this GitHub stuff pretty soon.
Cool. Yeah, we'll make sure that's posted in the server. Make sure you fill out the feedback form. That really helps us in making these things good for you guys and going over things you want to learn. So make sure you do that for us. But other than that, I think we can call it a day. And thank you all so much for joining in and participating. It was really nice being able to go through this with all of you and answer all your questions.
Thanks, guys.
And thank you, Sam, for teaching us. We don't
You're
get to
welcome.
Thank you.
we don't get to learn networking in this game design program. So to be exposed to this was really, really awesome.
Of
I think
course.
we all gained a lot of valuable insight into it.
Absolutely. I'm building actually a VR project within Unity, and we need to be able to